In Java, we often work with groups of objects. These groups can be organized and managed effectively using Java collections. The Java Collections framework provides a set of interfaces and classes to store and manipulate these groups of objects. Think of it like a toolbox with different containers for storing and organizing your data. These containers are designed to make your life as a programmer easier. They provide ready-made methods for adding, removing, searching, and sorting data. This saves you from writing a lot of code from scratch. The Collections framework is divided into 4 main interfaces: Collection, List, Set, and Map. Each interface represents a different way of storing and accessing data. Understanding these interfaces is key to mastering Java collections, as they form the foundation for all the collection classes you'll encounter. In the following sections, we'll delve into some of the most commonly used collection classes, providing clear definitions and practical code examples. An array list is like a resizable array. It allows you to store elements in a specific order. You can access elements by their index, which starts from 0 for the first element. One of the main advantages of ArrayList is that it grows automatically as you add more elements. You don't need to specify its size beforehand. Java import java.util.ArrayList. Public class ArrayList example, names add, Bob, names add, Charlie, / print, the ArrayList / access, an element by its index / remove an element / print, the updated ArrayList. This code demonstrates how to create an ArrayList, add elements, access elements, and remove elements. A linked list is another type of list, but it stores elements differently than an array list. Imagine a chain of nodes, where each node contains an element and a reference to the next node. That's how a linked list works. Linked lists are efficient for inserting and deleting elements in the middle of the list because you only need to update the references of the surrounding nodes. However, accessing elements by index can be slower than in an array list because you have to traverse the list from the beginning. Java import java.util.LinkedList. Public class linked list example. This code shows how to create a linked list, add elements at the beginning and end, and print the contents. A hash set is a collection that does not allow duplicate elements. It uses a mechanism called hashing to store and retrieve elements efficiently. When you add an element to a hash set, it calculates a hash code for that element and uses it to determine the element's position in the set. Hash sets are useful when you need to ensure that a collection contains only unique elements. For example, you could use a hash set to store a list of unique usernames. Java import java.util.HashSet. Public class HashSet example, colors add green, colors add blue, colors add red, / duplicate element, won't be added / print the HashSet / check if an element exists. This example demonstrates how to create a hash set, add elements, and check if an element exists. Notice that the duplicate red element is not added to the hash set. Section 5. Tree sets. A tree set is similar to a hash set in that it also stores unique elements. However, a tree set maintains the elements in a sorted order. It uses a tree-like structure to store the elements, which allows for efficient searching, insertion, and deletion operations. Tree sets are suitable when you need to store unique elements in a specific order, such as maintaining a sorted list of usernames. Java import java.util.TreeSet, public class TreeSet example, public static void main string args, TreeSet fruits =new TreeSet, fruits add banana, fruits add apple, fruits add orange, system out println fruits, / output, apple, banana, orange, system.out.println, fruits.first, / output, apple system.out.println, fruits.last, / output orange. This code example shows how to create a tree set, add elements, and retrieve the first and last elements. Section 6. Hash maps. A hash map is a collection that stores key-value pairs. Each key must be unique, and it maps to a specific value. You can think of it like a dictionary, where each word or key has a definition or value. Hash maps are efficient for retrieving values based on their keys. They use a hash function to calculate the index of the bucket where the key-value pair is stored. Java import java.util.HashMap, public class HashMap example, public static void main string args, / create a hash map of string keys and integer values, hashmap ages =new hashmap, / add key value pairs to the hashmap ages, put Alice 25, ages put Bob 30, ages put Charlie 28, / print the HashMap system, out println ages, / access a value by its key system, out println ages.get Bob, / output 30 / remove a key value pair, ages.remove Alice, / print the updated HashMap system, out.println ages. This code snippet demonstrates how to create a HashMap, add key value pairs, access values by keys, and remove key value pairs. Section 7. Practical example, using collections together. Imagine you're building a simple inventory system for a bookstore. You need to store information about each book, title, author, and price, and be able to quickly find books by their title. You could use a HashMap to store this information. The book title can be the key and the value can be another HashMap containing the author and price. Java import java.util.hashmap, public class bookstore inventory, HashMap book 2, =, new HashMap, / find a book by its title systemout.println book found plus book title, systemout.println author plus book details, get author, systemout.println price $ plus book details, get price. This example showcases how to use a HashMap to create a simple bookstore inventory system where each book title is mapped to its details such as author and price. Section 8. Choosing the right collection. With so many collection types available, choosing the right one for your needs is important. Here are some things to consider. Do you need to maintain the order of elements? If yes, use a list like ArrayList or LinkedList. If not, consider a set. Do you need to store unique elements? If yes, go for a set like HashSet or TreeSet. If not, an ArrayList or LinkedList would suffice. Do you need to store key value pairs? If yes, HashMap is your go-to choice. Do you need elements to be sorted? If yes, TreeSet for unique elements, or you can sort an ArrayList or LinkedList when needed. By considering these factors, you can select the most efficient and appropriate collection for your specific task. Section 9. The importance of collections in Java. Java collections are a fundamental part of the language. They provide a powerful and flexible way to work with groups of objects. Understanding and using collections effectively can greatly improve the efficiency and organization of your code. By leveraging the pre-built methods provided by the collections framework, you can save time and effort, writing cleaner and more maintainable code. Whether you're storing a simple list of names or managing a complex data structure, Java collections offer the tools you need to handle data effectively. As you continue your Java programming journey, explore the various collection classes and their capabilities further. Mastering Java collections will undoubtedly make you a more proficient and confident Java developer.